Okay, so we're just going to take a look at number 1. It says, which of the following equations represents an exponential function that decreases without bound? So one of the things that I always encourage you guys to do is to mark up keywords when it comes to a question. Which of the following equations represents an exponential function that decreases, which you should interpret to mean decay, and then without bound, meaning that it's not going to be approaching a number. So that could be something that's going to positive or negative infinity. So, and we're talking about the as x goes to infinity, what is the y value doing? So we're talking about the right end behavior. So one of the things that I want you to do is to be able to, at this point, sketch a quick graph of each one of these, 1, 2, and 3. So if you look at 1, the 3/2 represents growth, but it has 1 reflection. So that means it's going to be decay. All right. And so remember that the parent would be the one in black. So this is growth with no reflections. And then the only reflection is against the x-axis. So right here, that is going to be decreasing without bound. Let's take a look at number 2. We've got decay with no reflections. All right, this is just the constant, which could put at the end of the equation, and we would end up with a positive A value and a positive X value. So that's just decay at a decreasing rate. So notice that that picture isn't going to be included. And then this one is going to be growth with 1 reflection. So we do have decay, but notice again in black is the parent with no reflections, and the purple is just the y-axis reflection. So you can see that it's decay, but it is bounded. So the only choice there would be A. And then let's take a look at 2. 2 says identify the range of this function. Now, notice that this constant is going to be your horizontal asymptote. So the graph is either going to be above or below based on this A value. Since it's negative, your graph is going to be somewhere down here underneath this asymptote. So that means we're going to have negative infinity all the way up to positive 1. And of course, not including because it's an asymptote. So let's take a look at 3. We've got this point 2, 4, and then it's this is the graph 2 to the power of x, and then we have to identify those transformations. So if we look here, we are looking at multiplying the x by a -1. And then we are going to have to add 3 to it. So let's actually just figure out if we're moving it left or right. So negative x plus 3 equals 0. So negative x equals -3, and then x is equal to positive 3. So that means we are moving it 3 units to the right. All right, so what we need to do is then understand that we're taking the x value, we're reflecting it, and then we're adding 3. So that's how I'm coming up with that rule. And then the y value is just whatever that y value is, and it looks like all we're doing is adding 1 to it. So that's why I wrote that rule. So let's take that 2. So 2 times -1 is -2 plus 3 is 1. And then 4 plus 1 is 5. So we're looking at the point 1, 5. All right. So on number 4, we are looking at the idea of solving the equation, and we need to get it down to the same base. So you can take a look, and I wrote down the bases with a base of 2, and then applied the rules of exponents. When it's a power to a power, you're multiplying. And then now that all of the bases are the same, we take each of these exponents, and then we are, remember when you're multiplying, you're adding, and then it equals this side. So I'm just rewriting it as an algebra equation. Now I'm just going to go ahead and solve. So I've got 2x and 5x is 7x. Again, I'm just combining like terms. I'm going to add the 2x over here to this side, so it's going to make it 9x. And then I'm going to subtract the 6 that I just said was there. So I'm going to subtract the 6. So I got 9x equals -2. Divide by 9. And I get -2/9. And so we can see that for number 4, the answer would be D. All right, number 5, if we take a look at our equation, look at this. Do not just assume that it's 0 because you don't see a constant at the end. Pay attention. It's -4 minus 2x, 2 to the power of x plus 2. So rewrite it. It's -2 to the x plus 2 power. This is your constant. So your constant is -4. So your answer for number 5 is A. You have to just pay attention to detail. So let's take a look at number 6. It says consider the exponential function, and it gives you the form right here. And it says it's graphed at the right. Which of the following are true? So let's go through this and figure out which ones are true or not. It says the value of C is -3. Well, -3 is right here, and C is the horizontal asymptote. And so that is correct. So we know that Roman numeral 1 is good. So that means we can get rid of B and C already. All right. So now let's take a look at number 2. It says as x approaches infinity, the graph decreases with a boundary. So it's decay, and it's going to go to a boundary. And this is a decay graph, and it does go to a boundary. So Roman numeral 2 is also right. So we can eliminate A. So now we're down to either 1 and 2 only or 1, 2, and 3. So now the problem is we need to figure out what our B value is. We kind of look at this as working backwards, right? So notice that if we take a look at our function that they gave us, and you can see that I put in the -3 here. Now we're not going to solve the actual equation, but what we're doing is taking and looking at the number of reflections. We can assume that A is positive because there is the graph is above the horizontal asymptote. So that would indicate that this -x is one reflection. So in order for us to have a decay and involve one reflection, then that means I had to have started off with a growth function, because growth with one reflection turns to be decay. So that means our B value needs to be a value that represents growth. And when B is greater than 1, that represents a growth function. And so number 3 is also right. So our answer choice is E. Now let's take a look and kind of the same situation here. We've got our graph, right? We've got our function. Notice though that x is no reflection with that positive x. But now we need to look and see if our graph, it says our graph is below that horizontal asymptote, which means the value of A is less than 0. So I know that Roman numeral 1 is correct. So that means I can eliminate B and D. Now, the next easiest thing to identify is the value of C. So the value of C is that horizontal asymptote, so that one is also correct. Well, all right, so now I can eliminate answer choice A because it didn't include part 3. And so now I'm down to whether or not this is correct or not. So think about it like this. Let's identify what's happening with the graph. It is growth at a decreasing rate. So, and we also know that A is negative, so that means there's one reflection only. So in other words, what type of graph do I get with one reflection turns into growth? So something with one reflection equals growth, which would make this decay, because decay with one reflection is growth. Does this B value indicate a decay? And yes, it does, because it's a number between 0 and 1. So 1, 2, and 3 is correct. So C is my final answer.